Hello everyone. Today we're going to talk about what Floyd-Warshall algorithm is, and this is also known as all pairs shortest path, and let us look into it. So what is Floyd-Warshall algorithm? And it is an example of dynamic programming. It is an algorithm for finding shortest paths in a weighted graph, and it finds the length of the shortest path between all pairs of vertices. Yeah, so when we look, this is an example. We will take four vertices A, B, C, D, and then let us look at the distance between D and B, which is from D to B, right? So from path 1, it goes from D to A and A to B, which has total length of 14. So path 2 have D to A to C, and C to B. So which has a total of 10, which has a total length of 10. So path 2 is the shorter distance than part 1. So part 2 is the shortest distance between D to B. So similarly, for each pair of vertices in the graph, we will be able to find out the shortest distance using Floyd-Warshall algorithm. So there are some nodes. There can be more than one route between each pair of nodes. The number of nodes in the route is not important, and the shortest path is not unique. There can be more than one path of minimal length. Yeah, so firstly, using the graph, using the given graph, we will be able to find out the distance matrix D naught. And as you can see here, uh, the diagonal elements are all zero because this is a simple graph and there are no loops which starts from A and ends at A. So there are no loops here. So all the principal element is zero. So from A to B, from the graph we have 9. There is a direct path between A to B and it has a length of 9. So we will write here 9. And then similarly from A to C, there is a direct path from A to C and the length is 2. So we will write it as 2. So in the case of A to D, even though there's an edge, it is not directed towards D, it is directed towards A. So from A to D, there is no direct path, so we will write it as infinity. And using the same logic, we will fill out the other elements of the D naught matrix. So yeah, and then for Floyd-Warshall algorithm, we will check for dik plus dkj lesser than dij from the from the previous distance matrix. So if the condition is true, then we insert the value of dik plus dkj in dij for the current distance matrix dk. So as I go on, we will understand what this actually means. So here for the first iteration for k is equal to 1, we will set the first rows and first columns to be fixed. We will fix the first rows and first columns, and yeah, and then see the first rows and first columns are similar with the previous matrix D naught, which is 0, 9 to infinity, 0, 9 to infinity, and then 0, infinity, infinity, 5, 0, infinity, infinity, 5. And since it is a simple graph, all the principal elements are 0. So we will keep it as like this, right? So for k is equal to 1, we will check for here k is equal to 1. So the first one is A. So since we fixed A, so d of ia plus d of aj lesser than d of ij from d naught. Yeah, so in this case, yeah, d of ia plus d of aj lesser than d of ij from d naught, right? So here I is equal to b, and let I is equal to b and j is equal to c, that is b, c, which is this particular cell, right? So from here I is b and j is c, right? So we will check d of ba plus d of ac lesser than d of bc from the previous one. So let us look here. D of ba is infinity, and d of ac is 2 less than d of bc from the previous bc from the previous distance matrix is infinity, right? So here infinity. So this condition infinity plus 2 is infinity, infinity lesser than infinity, so it is not lesser than infinity, the condition is not true. So we will write the we will keep the element as it is. So from the previous element it is infinity, so oh, we will excuse me, yeah, sorry about that. So from there it will remain as it is, right? So this will be infinity. And let us look at for I is equal to b and j is equal to d, that is I is equal to b and j is equal to d. So I will be b and j is d, so distance of ba plus distance of ad lesser than distance of bd. So distance of ba here is infinity plus distance of ad is also infinity lesser than distance of BD from the previous matrix. Distance of BD from the previous matrix is 2. So infinity is lesser than 2 is not true. So it will remain as it is. Yeah. So we will consider I is equal to D and J is equal to B. I is equal to D and J is equal to B. So for this particular element, D of distance of DA is 5. Distance of AB is also 9. So less than distance of dB. This is distance of dB here from the previous matrix is infinity. So it is 9 plus 5 is 14 is less than infinity. So we will write here 14 less than infinity. So we will insert here 14. Similarly, in this logic, we will continue to fill out the elements of D1 matrix. So here, this is the obtained D1 matrix, and then we will go to the next iteration, which is for k is equal to 2. So for this, yeah, so here there's some correction before initially before it was written a, so for k is equal to 2 it is supposed to be b. So in this case it will be d of ib plus d of bj less than d of ij from d1, which is from the previous distance matrix, right? So here we consider I is equal to a and j is equal to c. I is equal to a and j is equal to c, which is this one, and d of ab is 9 plus d of bc is infinity less than d of ac from the previous matrix. D of ac from the previous matrix is 2. So infinity is not less than 2, which means that we will put the value as it is. Right. So similarly, a of ad for ad, d of ab is 9 plus d of bd is 2 less than d of ad from the previous matrix. D of ad from the previous matrix is infinity. So here 11 is less than infinity. So which is a true condition. So we will write here 11. Right. So similarly, for I is equal to c and j is equal to a, so we will look at d of cb plus d of ba. D of cb is here 3 plus d of ba here ba is infinity less than d of d of bc from the previous matrix, infinity. So this is infinity less than infinity, so it will remain as infinity. Yeah. So similarly, we will fill the values accordingly, and we will get the D2 matrix. So here is the calculated one, D2. So this is the obtained matrix, and then for k is equal to 3, that means iteration 3. And in this case, we will check d of ic plus d of cj less than d of ij from d2, right? So here we will fix the third columns and third rows, and then we will uh, fill the elements accordingly. So for here, I is equal to a and j is equal to b. That means for this element, we will check for d of ac plus d of cb less than d of ab. So d of ac is true, and d of cb is 3, less than d of ab from the previous one, d of ab from the previous matrix d2, which is 9. So 5 is less than 9, so we will fill here 5, right? So similarly, I is equal to a and j is equal to d. We will check for d of ac plus d of cd less than d of ad. So here d of ac is true, d of cd is 5, less than d of ad from the previous matrix. The right hand side will always be from the previous matrix, d of ad, which is 11. That means 7 is less than 11, which is true. So here we will write 11. 7, sorry. 7. And then for b is equal to I is equal to b and j is equal to a. That means for this particular cell, we will check for d of bc plus d of ca less than d of ba. So d of bc here is infinity, and anything if you add with infinity, it will always be infinity, right? So we will check for d of ba from the previous matrix, which is also infinity. So infinity lesser than infinity, it will always remain as infinity. So the condition is not true, so we will write it as it is. So similarly, we can carry on and find out all the values of these three elements here. And these are the d3 elements, and we will go to the last iteration, k is equal to 4, and for this k will be d. So here d of d plus d of dj is less than d of ij from d3, right? So for I is equal to a and j is equal to b, that means for this particular element, we will check for d of ad plus d of db less than d of ab. So d of ad is 7, and d of db is 10, less than d of ab from the previous one. D of ab from the previous one is 5. That means 17 lesser than 5 is not true, so we will write the previous element here. Similarly, AC, we will check for D of AD, which is 7, plus D of DC, which is also 7, lesser than D of AC from the previous element, which is 2. This is also not true. That means 14 is not lesser than 2, so we will write it as 2 here. No change in the element. So here I is equal to b and j is equal to a. That means I is equal to b and j is equal to a. That means for this particular cell, we will check for d of db plus d of da lesser than d of ba. D of db is 10. D of da is 5, lesser than d of ba from the previous matrix, infinity. So 15 is less than infinity, right? So here we will write is 15. And similarly, we can find out the elements of d4. So wait, let me recheck here again. D of bd is 2, d of da is 5. less than d of BA infinity, which is 7 less than infinity. Yeah, so here this is should be 7, right? So yeah, so using this we can find out the elements of D4. So these are the elements of D4, and then here we are obtaining the all pair shortest path. That means for all pairs of vertices, we are obtaining the shortest length of the path between the vertex. So here from A to B is 5. That means that it goes from A to C, that is 2, then C to B 3. From if it goes direct, it is 9, right? So AC to CB, the total length is 5. So 5 is lesser than 9, so this is the shortest length. So here we obtained the shortest path of all pairs of vertices. So that is the Floyd-Warshall algorithm, which finds out the shortest length of all pairs of vertices in a given graph. Thank you.